Welcome, 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 everybody. Thanks for spending some time with us today, Friday. Either you should be working or you are working, or you're going to sit here for a good hour with us, and we appreciate your time. But we do want to say thank you to Aircraft Spruce for sponsoring these webinars for this today, tomorrow, and on Sunday. Is kind of hand the floor over to Vince. So we have Vince, who's the Director of Aftermarket Sales, and obviously with Tempest Aero Group. So at this point, let's take everything over to Vince, and we'll discuss the spark plug design.
Thanks, Kent. I really appreciate everybody coming in, and glad that I was invited to be able to speak again this year. It's always an exciting time. Unfortunately, I wish we were here in person, but I'm still glad that we're able to get together. And as Kent said, feel free to ask questions, and we'll definitely try to get to any of your, answer any of them as much as we can. And if we don't get to them, I will have my email address, my phone number, as well as many of them probably can actually be answered just by going to our website at tempestplus.com. So with no further ado, I'll share my screen here and see if we can get start with spark plug design and maintenance. All right, I think we're here. So as Kent said, and I said earlier, we'll get going on spark plug design and maintenance here. I guess the big thing to start in the background that's new, if you haven't been to one of our presentations before, is Tempest Aero Group. And as Kent said, I'm the Director of Aftermarket Sales for Tempest Aero Group. And Tempest Aero Group now serves as the engineering and the sales and marketing arm of these affiliated companies, which you'll see is Tempest is what we're talking about today, Alcor, Marvel Chevrolet, Precision, and Consolidated Fuel Systems. We have manufacturing facilities in Burlington, North Carolina, up in just outside of Seattle, Washington, and San Antonio, Texas, is where these different facilities are located. But whenever you see the Tempest Aero Group banner, I think it's important to know that you also can talk about any of these other product lines or any of these other companies. So to get started on spark plugs, Tempest was able to get into the spark plug business December 31st of 2010. We went in and purchased the Unison Autolite line. They were made out of Rockford, Illinois, and we moved them into our Burlington, North Carolina facility. And we actually spent about 6 months going through and re-engineering this spark plug. Some of the things that we did, I think, that to improve it and where we've gotten our reputation from is number one, the one-piece resistor design, which I'll get into as we go through the presentation. We also went with a more robust insulator design that will withstand core nose cracking from some of the environments that you're seeing, particularly in these bigger turbocharged engines. We've also gone with a electroless nickel plating, which I'm never going to sit here and tell you you're never going to see corrosion on a spark plug, but it definitely holds up much better than the standard zinc and silver paint that had always been used in the past in spark plug designs. Some of the quick things, normally I show a video, but since we're doing a webinar, I'm unable to do that. So if you have an opportunity, please go to the website. Again, it's www.tempestplus.com, and there is a video there that actually goes through the entire process of our spark plug manufacturing. But since I can't show the video, I'm going to show you a few pictures. This is our screw machine. This is actually what I would say is what we do our boutique plugs. In particular, any of the plugs that we put on an electronic ignition system. This machine actually manufactures the barrel and the sleeve of the plug. We use what we call an Acme machine for the standard plugs that are out on your Lycomings and your Continental engines that are just using a standard magneto system. And those particular machines, they can pump out a barrel and a sleeve in around 10 seconds at a time. So it's pretty amazing. This is a vacuum cement process, and all this machine is showing you is that the center electrode in the insulator, there's a vacuum cement seal in the plug, and this is important because we don't want combustion gases getting through the plug. And I'll get a little more into this in a minute, but this is what this machine does, is putting that vacuum cement seal between the insulator and the center electrode. This is our fully automated robotic machine. So once we have the barrel made, the insulator, your ground electrodes, we're able to assemble the plug on this automated robotic production machine. And this machine not only will build the plug, but it also can fire the plug. It can do a leak test on the plug, and then lets us know if the plug is obviously firing through the fluid that it's being run under. Pressure check. This is just another machine that we use off of the side. Again, this is checking the pressures of the plug and making sure the plug's not going to leak. And that's extremely important because when you talk about combustion gases, you don't want to get that, your spark plug in particular, you don't want combustion gases to get through the spark plug. As they get through the spark plug, you can potentially damage the harness. And again, I'll talk about that some as well. So basic design of a spark plug. And I think this is important because when I get on the phone and we're start talking or start trying to troubleshoot a spark plug or just talking about ignition systems in general, I find that sometimes we're not always on the same page when we're talking about particular items or particular parts of a spark plug. So I like to go over this first. I know this is pretty basic stuff, but I think it's important to know your ground electrodes. They're made out of nickel for your massive plugs. It's iridium for a fine wire plug. Your center electrode on a massive plug is a nickel sleeve and a copper center core. And the reason we use a copper center core is it's got a great conductor. It's high conductivity. The downside to using a copper center core is that if we don't use if we just left it pure copper, it doesn't like 100 low lead. So that's why you see the nickel sleeve on it. Your high alumina ceramic insulator, that particular insulator again is going to be more robust. It's going to hold up under more extreme conditions. In the past, the initial spark plugs were actually using porcelain, which had issues with absorbing oil and cracking in the early stages of spark plug design. The vacuum infused center electrode. So again, between the center electrode and the insulator, we are making sure no combustion gases can get through that spark plug. And the big issue here is that if you have a leak or that spark plug has a leak, it can go through the plug, it can go through the harness. And I don't know if anybody's ever seen it happen, but from time to time you will see that harness can get plump and almost look like if you're grilling a bratwurst. And obviously those are things that we don't want to happen. It can seriously damage the ignition system. The one-piece resistor design. This is was our big claim to fame when we introduced a spark plug, is going to a one-piece resistor design. It's a more stable design. It holds up better over time. And again, we'll get into a little more depth into a one-piece resistor here soon. Your hot lock assembly. All this is essentially, if we can break down the plug, there's three basic pieces of the plug, and that's your insulator, your barrel of the plug, and maybe you can see this on a picture, but your barrel of the plug, so the firing end of the plug, and then your sleeve of your spark plug, which is the lower end where your B-nut or your harness is going to attach to. And those three pieces need to be compressed together, otherwise they'll separate during the combustion cycle, and this is what we use a hot lock assembly for. Your harness wire contact, that's for us, we don't have a screw slot. It's all one piece. It's all part of our one-piece resistor design. And again, it's a more stable, and it's not going to allow any kind of leakage into the plug from an internal standpoint. And your electroless nickel finish. And I spoke about this earlier, but it's just going to hold up better over time as we're operating these plugs in the type of environment that we are. So with that said, when we start looking at these spark plugs and we consider all the different piece parts of them, not only all the different piece parts, but the environment that these spark plugs are in, they're going to fire about 8 million times in 100 hours. That's about 22 times a second. That's they can withstand up to 4,000 degrees, 2,000 PSI, 24,000 volts to 25,000 volts for a standard mag. When you start talking electronic ignition, the voltage jumps way up above that. And these spark plugs can handle that as well with a different gap setting. But these are different things that are all important if we want to get the full life out of plugs. So when we're talking on average, you're getting 500 hours out of a set of massive plugs, and somewhere between 1,500 and 2,000 hours out of a set of fine wire plugs. When you consider 22 times a second, they're running in 100 low lead, and again, the type of engines that they're running on, we're getting a pretty good life out of these spark plugs. Part number designation. I think this is really simple, but again, I think it's important because we get a lot of people that'll come up and they'll tell us that it's a 40 or a 38, which is the heat rating, but they don't know what size B nut they're using or what length plug from a firing end, whether it's a long reach or a short reach plug that they're using. So to start that off, our brand designator is a U, and most of you are, how do you get a U when your brand or when your name is Tempest? For us, it was really simple. If you're familiar with other products, we wanted to use an AA, which has always been our brand designation. But in this particular case, the FAA said, if you'd like to do that, that'd be fine, but you need to recertify all of your plugs. And we decided that the U was a great brand designator after that. The R is our resistor design. All aviation plugs, or the majority of aviation spark plugs, are going to have a resistor in them. The H that you see next is your barrel size. And when we start talking about a barrel size, we have two different types of barrels. You're going to have a big barrel, which is your H, which is your 3/4, and you're going to have a small barrel, and that's going to be your 5/8 spark plug. And these were all designed, the large barrel was designed during World War II, and at that time, that was allowing when we were starting to get higher altitude with the type of airplanes we were flying. And a lot of times you'll hear people call these all-weather plugs, and it just has to do with the plug can still or continuously fire in that higher altitude. Let's see. Your bead, or your next designation, is your mounting threads. On that mounting thread, I always remember this is big and mini. So your B is your long reach. Typically the plug we're looking at right now, which is a URHB 32E, these are Continental engines. A lot of the UREM or the small bear or the short reach plugs are going to be Lycoming. That's not always the case, but that's kind of the general rule of thumb. So again, your B is your long reach, a 13/16 reach of the plug, versus the M is going to be a 1/2 inch reach of the spark plug. The heat rating system. When we're looking at this in particular, this has nothing to do with Fahrenheit. This has nothing to do with Celsius. This is all based off an engineering chart. There's actually two machines, or two, I think they're called IMEP engines that are insulator engines to determine the heat rating of these spark plugs. Unfortunately for aviation, neither spark plug manufacturer owns one of these engines, so we get very little time on them to test different heat ratings. For Tempest in particular, our coldest spark plug is going to be a 32E, and the hottest spark plug that we manufacture is going to be a 40E spark plug. And again, this has nothing to do with Fahrenheit or Celsius. It's strictly to do with an engineering chart. So the lower the number is, the cooler this plug is, and the higher the number is, the hotter that spark plug is going to be. The last designation for our spark plug is your Electrode Design. Again, E is our massive spark plug. These are going to have your 2 ground electrodes. The S is iridium, and that iridium is going to be a single electrode. And then the third designation is your BY. And these are the only spark plugs that come with a BY designation is a UREM 37BY, and they have a projected core nose, and they were actually designed for some of these smaller engines that are out there that were built and engineered pre-100 low lead. And we'll talk about that some as well. Resistor comparison. So when I talk about resistors, if there's one thing I speak about today, and it's the only thing you remember, I think resistor is going to be the most important thing that we discuss today. So your past spark plugs, they were what we called a multi-piece or a stack resistor design. They used a silicon carbide resistor. they had a tendency that over the life of the plug, the resistor would actually break down. And when a resistor breaks down, it starts causing hard starting, rough running, misfiring. It can actually put a lot of stress on the ignition system to the point where it actually will burn or can melt the cover off a coil on a magneto. So knowing this and knowing that this particular resistor design has a hard time operating in today's environment, what you'll see in the marketplace is a one-piece resistor. This one-piece resistor is more stable over the life of the plug. It will hold up and stand somewhere around, for a Tempest, around 1,500 ohms. We say that if it ever gets above 5,000 ohms, that we need to replace the spark plug, and it's actually got a lifetime guarantee on it when it comes to the resistor design. So again, if it ever gets above 5,000 ohms, we'll replace that spark plug. The next question, I think the most important, or one of the most important things to get is, well, why do we even have a resistor? What's the point of a resistor on these spark plugs? And the point is that we have, or the reason for this is, we have a shielded ignition system. And with a shielded ignition system, we get capacitance after fire. And that capacitance after fire can, if we did not have a resistor, will cause the ground electrodes and the center electrodes to wear out much faster. So if the resistor is doing its job, it's there to absorb or dissipate that capacitance after fire that we get from a shielded ignition system. And that's its main purpose. I know a lot of people will say, oh, it's there to suppress headset noise. And yeah, it will help with that, but that's not its main purpose. Again, it's designed to absorb or dissipate that capacitance after fire. When we look at resistance and you look at any of the specs, and again, this is something you can find on our website, but if you look at the specs here, a brand new plug coming out of the box should be somewhere between 500 and 3,000 ohms. Typically, they're going to be somewhere around let's say 1,000 to 1,500 ohms. A good plug that's been used should be between 500 and 5,000 ohms. And a plug that you should contact us about, as long as the electrodes are still operating or still looking good, is anything over 5,000 ohms. That would meet the requirement that they need to be replaced, and that you're going to start putting added stress on that magneto and that spark plug in general. And again, it would qualify as under our lifetime warranty for the resistor. The other side of this is that you won't see very often, but is the 500 ohm section here. When we start talking about 500 ohms, if you get on the low end of this is where you start getting so low that you're no longer absorbing or dissipating that capacitance after fire, and your ground and center electrodes will start to wear out. If any of you ever remember the old AC spark plugs, they used a 3-electrode design, and this is why they used a three electrode design. They actually had a precursor to what we look at as today's one-piece resistor, and they were having issues with the electrodes wearing much faster, and so they needed to somehow more even wear and reduce that, so they added a third electrode, or third or ground electrode, to the spark plug. The AT5K. So when we're looking at these plugs and we're trying to figure out what the resistance is, you can do a couple different things. You can use an ohm meter, which the previous slide showed an ohm meter that you could use, and most everybody's got that in their toolbox. Or a much faster way to do this, and it's just a go, no-go gauge, is the Tempest AT5K. You, number one, want to make sure the ground and center electrodes, the firing and the plug is clean. You hit the start button, the red light will come on. You'll put the plug on the stud. And once the plug's on the stud, then you'll take the lead and put it on its center electrode. And green is good. It means it's under 3,000 ohms. Red means it's above 5,000 ohms. And if the plug starts to flash or the lights flash back and forth, that's letting you know that you are in a area of 3 to 5, and it's just something you should continue to monitor as you're going through the life of that spark plug. The last thing I'm going to mention on resistance is that resistance isn't something Tempest came up with. It's not something we made up just to sell more spark plugs. This has got a mil spec that goes back to 1962 and actually goes back before that. but this particular mil spec was March 13th of 62, and it specifically calls out using an 8-volt meter or less to check the resistance of a spark plug. And this was something that was a standard practice in the past when you were cleaning and gapping and doing general maintenance on a spark plug, and somehow over the years it slowly went away. And I guess what we're here today is just to really stress the point that not only do you need to clean and gap the plug and use a spark plug tester, but you need to use that ohm meter or that AT5K to check the resistance on a spark plug. Fire and end comparison. So we mentioned this a little bit earlier, but this just gives you a visual of it. We have a long reach and a short reach. So again, your B is your long reach plug. This is most commonly going to be on a Continental engine, where your short reach plugs, they're going to have an M designation, and they're going to be more commonly on your Lycoming engines. When we look at spark plug reach, the reason this is important is, in particular, is the type of cylinders we've got. You have long reach cylinders and you have short reach cylinders. And if you're putting a long reach plug in a short reach cylinder, you're going to have issues with hot spot. You're going to have issues where you could potentially damage the piston and actually hit the piston and hit the firing end of the plug and damage the piston itself. And then you're going to have a lot more issues than worrying about a spark plug. The middle picture is actually showing a short reach plug and a long reach cylinder. And again, this will have issues with hot spots. It'll also have issues with lead building up, and this can cause pre-ignition. So it's important to make sure you're using the right reach spark plug on the right cylinder. Hot and cold, or spark plug heat rating. So we mentioned earlier, the lower the number is, the cooler that plug's going to fire. The higher the number is, the hotter that spark plug is going to fire. When we're looking at this and looking at the plugs in general, one of the things that gets brought up to me quite a bit, and particularly at Oshkosh, is that people, for some reason, assume that if they have a long reach plug, that means that they're going to have a hotter spark plug that's going to take longer to dissipate the heat and cause that plug to run hotter. And that's not the case. The reach has nothing to do with your heat rating of the plug. What we're doing is we're looking at the tip of the cornose, which you can see those arrows coming from the tip of the cornose to the shoulder of the plug. So where that, or the shoulder of the insulator. So you can see where the shoulder comes out and actually butts up against the firing end of the plug. And if you look here, the cooler plug on the left is a long reach plug, but it's got a shorter depth on the insulator design, where our plug on the right is a short reach plug, but the depth is longer, and it's going to take longer for that plug to dissipate the heat, which makes it a hotter spark plug. And that's how we're determining heat. It's all based on the insulator design. It has nothing to do with the reach of the spark plug. If I could design a perfect spark plug for you, and we would design it for all plugs to sit right around 1100 degrees. Spark plugs that could stay right around 1100 degrees are going to see the least harmful deposits. They're going to run without any issues for the longest period of time. Unfortunately, we've got so many different engines and we've got so many different designs out there that that's almost, well, it's impossible to do. So when we're looking at plugs, if we're able to measure truly measure the heat of the firing end, or the firing end of the plug, the cold end here is going to be 800, 600 degrees. And when we're looking at that, that's when you're going to start to see carbon fouling. You can also get cold fouling from lead as well. When we get up into the higher temperatures, we're talking 13, 14, and 1500 degrees. That's where lead starts to become conductive. And you'll see lead fouling at the higher temperatures as well. But the concern is when it gets conductive, it's going to continue to get hot, and that's when we get into the pre-ignition range. And these are all things that we're concerned about when we're looking at the heat range of a spark plug and how that spark plug is operating in its particular engine environment. The 3 electrode designs, and just again, another visual, we talked about this earlier, but your upper right picture is your massive spark plug. Your lower right picture is your single wire or fine wire spark plug, which is going to be designated by an S. And then the plug off to your left is our projected core nose, which is a BY spark plug, or a 37BY spark plug. Spark plug service tips. When we're talking about service tips of the plug, we talked about the insulator earlier. The insulator is extremely robust. It's going to hold up to the environments of today's engines, but it's also extremely brittle. And when I say that it's robust and hard, it's actually hard as a diamond. But if it gets dropped, it's still going to crack. So the saying that if you're an A&P, and I think it's one of the first things you learn in A&P school, is if you drop it once, you drop it twice, and the second time you drop it, it's going in the trash can. And that means if you've dropped it from your workbench to the floor, or if you just dropped it on your workbench, it's something to consider and look into. And the reason we say that's so important is if you look at this particular picture of this plug. This is a fine wire plug that actually came off a friend of mine's aircraft, and he had a couple hundred hours on it. And if you look at the center electrode, it's completely worn out. Not only does the plug have carbon and oil all over it, so you can tell it's been cold and it's not firing, but you can see the center electrode it looks like a paper clip in only 100 hours. And these plugs should be getting somewhere between 15 and 2,000 hours out of them. We got the plug back. We put the plug on a bomb tester or a spark plug tester, and we found very quickly that the plug would fire, but it fired intermittently. We cleaned the plug to see if that made any difference. It did not. And the very last thing that we did, or I should say the second to last thing we did, is we obviously did a visual inspection, and we could not find any cracks on the firing end of the plug or internally on the where you would put the harness inside the barrel or the sleeve of the plug. So what we did is we took the plug and put it on a lathe, and once we put the plug on a lathe, you could see that internal, where we were unable to look at the plug, it had cracked, and we believe that it had a hairline fracture to start off. They put it on a bomb tester and could not see anything wrong. It still fired, and as that plug got put back on the engine and that engine heated up, that hairline fracture began to expand, and you started to see the intermittent fire of the plug. And the only electricity or the only voltage that was reaching that plug was to the center electrode, which caused it to completely wear out. 6-point socket. When we're looking at a 6-point socket, the big thing here is we're just wanting to use not only a 6-point socket, but a deep well 6-point socket that is designed specifically for aviation. And the reason we say this is we don't want to put any added stress on the sleeve of the plug. If we're putting added stress on the sleeve of the plug, we can potentially crack that portion of the insulator and again, not get the life that we'd like out of the spark plug. Your lead wrench. It's important to use a lead wrench when you're installing a plug. Not only installing the plug, but installing the B-nut. And the reason for that is we don't want to twist the lead wires. If you're twisting the lead wires, one, you can damage that particular lead, and two, you may not make good contact on the cigarette inside the terminal well portion of that spark plug. And if you're not making good contact inside that terminal well, you're going to get flashover, and that plug's not going to fire properly. So again, it's important to use a lead wrench. Firing end inspection. So when we're looking at a firing end inspection on the plug, this is pretty basic. I think these are things that most people know pretty easily, but on the left-hand side here, you'll see a brand new spark plug. On the right-hand side, you're looking at a worn-out plug, and what we determine as a worn-out spark plug is a plug with a center electrode that's a football shape, and your ground electrode is half of the original size. So again, a football shape on the center electrode, and the ground electrode is going to be half of its original size. And for these plugs, typically an average life for them is about 500 hours. This is a go, no-go gauge. It's pretty simple to use. You can get it from a lot of different tool stores out there. I think about Aircraft Tool Supply. I'm sure you can probably get them from Aircraft Spruce as well. But in particular, these tools are just, again, simple go, no-go gauge. You want to clean and gap your spark plug first. If the ground electrode and the center electrode will fit inside that little hole or that slot on the gauge, it lets you know the plug is bad and it's time to replace the plug. Carbon fouled plugs. So when we're looking at carbon fouled plugs, the big thing here is that you can get carbon fouling at low temperatures. You can get carbon fouling at high temperatures, but carbon fouling is conductive all the time. Typically in this case, when we get carbon fouling, we're running either too cold of a spark plug is typically what we see happen, particularly if you're running too rich at idle. These are just very common things that happen with a carbon foul plug. Most of the time you're able to run that engine or increase the horsepower of the engine until you're going to do a mag check. And when you're about to do a mag check, you let the engine sit there for about a minute at that RPM and allow that carbon to burn off. This is lead fouling. I mentioned earlier that lead fouling can happen at 2 different temperatures. And the way we can tell this is that on the left, and these are both extreme cases, but on your left-hand side, this is lead fouling at cooler temperatures. Again, it could have been just a cold spark plug. It could be a misdistribution of the lead or the tetraethyl lead in the fuel that can cause this on the left-hand side. But as that plug gets hotter and we get hot spots, if we're getting pre-ignition, those type of things, you're going to notice that you're getting lead that's being conductive and lead's at higher temperatures because the color of the lead's going to change. So it'll go from that tan color that you see on the left to the really dark color that you see on the right. And this is just a good indication that your plug is seeing adverse temperatures while it's firing or it not firing. And this is important. And we start talking about this. I mentioned earlier, some of these engines were designed for lower octane. Today's engines are all using 100 low lead. And while we say low lead, we've actually got 2 milliliters of lead per gallon in the fuel today, versus some of these smaller engines that were designed pre-100 low lead were all designed for 80 octane, which only has a 0.5 milliliter of lead. So when you think about low lead, we actually have more lead today, and these are why we have some of the issues you see with lead fouling on spark plugs. The URM 37BY. So we spoke about this design a little bit earlier, but it's important to know that you have your C90, your 0200, even going over to your 0320s, your 0360s. These engines, a lot of them were designed for the 80 octane. And when they went to 80 octane, went from 80 octane to 100 low lead, we started seeing significant issues with lead fouling and problems with the plug. And this is where you saw the spark plug manufacturers design and go to 37BY plug. This projected core nose it runs hotter at the tip. So it actually runs very similar as a 40, but the tip runs hotter. And because it's projected, it's going to burn that lead off. And it's also going to allow more lead to build up over time while the plug still fires. This is a great spark plug, particularly again for some of these smaller engines that are out there. I highly recommend it if you're having any of these kind of issues. The plug that you see on the right, which is also a 37BY, you'll notice that how much lead is built up on there. This actually came off at one time. The University of Illinois had a flight school, and this came off of their 0235 engine. And that 0235, when they pulled that plug, the lead, you can see the thread marks on the lead still, but that plug was still firing. So it's, again, this plug can withstand a heavy amount of lead and still fire, but that's its purpose, because these particular engines weren't designed for 100 low lead. Lead silicate fouling. So when we talk about lead silicate fouling, this is conductive at all temperatures, just like your oil fouling is. This is just harder to get rid of. Typically, when we see lead silicate fouling, it's due to dirty induction systems. If you have this, actually shows a picture of a gentleman in Texas that had a really dirty induction system, had not cleaned it out, had not cleaned the filter or replaced the filter, and he started getting some of this sand and glass into the plug and causing that lead silicate fouling issues. The other thing that's important here is that we always talk about if you're running too rich at idle. You can have issues where you're going to get carbon fouling and those type of things at cold temperatures. But when we're looking at it from a standpoint of running too rich, if we back off and we're running too lean at idle, we can see lead silicate fouling. So there is a fine line there, and it's something that to keep in mind particularly when you're idling your aircraft. Improper leaning. So as a spark plug manufacturer, I'm not going to get into lean a peak a whole lot. I'm just going to tell you that as a spark plug manufacturer, we have no problem with you running lean a peak. The key is that you run it properly. And whether you're following GAMI's system, I know Continental has their own recommendations, and I still believe Lycoming does not want you to run lean a peak. It's important that you're doing it correctly. And I find a lot of people that heard from a buddy, that heard from a buddy, that heard from a buddy how to run lean a peak. And if you don't know how to run it properly and you're not following those proper guidelines, things like this can happen where you're going to get that improper leaning and it looks like somebody took a chisel to the spark plug, and then obviously things get much worse where you get into detonation from there. So when we're talking about detonation, detonation is caused by two uneven air-fuel mixture or flame fronts. And when these two uneven air-fuel mixture, these two uneven flame fronts collide, they cause detonation. And when detonation occurs, you're not going to see a rapid rise. If you're able to monitor CHT, you're not going to see a rapid rise in your CHT. You may get a little bit of audible knocking. Unfortunately, most of the time when you finally figure out you have detonation or have a detonation issue, it's a day late and $1 short. Things like this occur. This is where a spark plug, again, it looks like somebody took a chisel to the spark plug. The insulator starts to crack. These are signs of detonation. If you look, so it looks like somebody took a sledgehammer to the piston. This is another sign of detonation. Now, when we talk about pre-ignition is a little bit different. When we're looking at pre-ignition, we can get a hot spot. So you could have from a spark plug standpoint, you could have too hot a spark plug. You could have hot spots that have lead that has built up on the plug or on the sidewall of the cylinder. You can have pre-ignition issues where the timing of the mag is off that can cause pre-ignition. These are all things that occur or can cause pre-ignition. If there's a positive to pre-ignition, which there really isn't, is that you will see a rapid rise in your CHT if you're able to monitor those, and that will be an indication I've got something going on and need to check to make sure I don't have pre-ignition occurring in the engine. These are just quick examples. Again, difference here is that it looks like somebody actually melted the insulator. That's how hot the spark plug gets during a pre-ignition event. And you can see where the center electrode actually melted and then cooled back off on the ground electrode. Your piston on a pre-ignition cycle, rather than looking like a sledgehammer, it looks like somebody took a blowtorch to it and actually will melt the piston. That's how hot the piston is going to get during a pre-ignition pre-ignition event. So cleaning, gapping, and rotating spark plugs. And I apologize. I usually like to go through, and I feel like people have questions as I'm going through this, and I can't see anybody. So hopefully we can get to everybody's questions here towards the end when we finish up. But cleaning, gapping, and rotating. There's multiple different ways to do this. When we're looking at it and the way that we look at it from as a manufacturer, the first one is, and let me go back here, is your vibrator cleaner. This can be used on both massive and fine wire spark plugs. We also recommend you can use a bead blast cleaner, but we recommend that you only use this on massive plugs. We don't want to exceed 80 PSI. The biggest thing that we see when people go to clean and gap their spark plugs is they over clean them. People want to take these spark plugs out. They want to clean them and make them look like they just pulled them out of the package brand new. And that's not what we're looking for. We actually prefer that you're under 80 PSI if you're going to do a bead blast cleaner on here, because we're just looking to get the big clunkers off of the plug. We're not looking to get the big clunkers out of the plug, whether that's lead, carbon, et cetera, oil, off of those plugs. Don't use sand or glass silicon. We don't want you to use those because it's conductive, and there's actually a manual available on our website that specifically talks about this and gets into some pictures. But that sand or glass silicon is conductive, and it can stay in the firing end of the plug. And when it stays in the firing end of the plug, it will either cause pre-ignition or can actually get lodged between the center electrode and the insulator, and that silicon bead will expand and cause the insulator to crack. So what we do think you should use is crushed walnuts. There's also a material called black diamond that you can buy through Aircraft Tool Supply. These are all non-conductive materials and good for cleaning the spark plug. The last thing, and what we really push towards when you're cleaning, in particular, fine wire spark plugs, is using Hoppy's number 9. Hoppy's number 9 is a great way to soften that lead, particularly on fine wire plugs, and just take a dental pick and clean that out. So what we would recommend here is taking Hoppy's number 9, taking a spark plug tray, putting the plugs in the tray, pouring the Hoppy's number 9 in the firing end of the plug, and letting it sit for 20 or 30 minutes to soften that lead, and then come back out and take a dental pick to it to clean. This is not an approved cleaning method. So when we're going through and cleaning spark plugs, I see people like to take a wire brush to the firing end. They like to see if they can make those that ground electrode and center electrode nice and sharp, so they think they're going to get a better, that they're going to jump the gap. The spark's going to jump the gap better. But ultimately, when people do this, we end up seeing wire get into the plug and causes the plug to foul out. So this is not something that we would recommend or approve from a cleaning, is using a wire brush on the firing end of the spark plug. If you choose to use a wire brush and you want to clean your threads, that's perfectly fine. Just don't be the person that's cleaning the threads that actually cleans them off. We've seen this only once, but it was A&P students. I won't say what school they were in, but they would clean these plugs, or had the opportunity to clean plugs before they go back into the flight school. And all the IAs that were the full-time maintenance staff would then go in and recheck the plugs and do an AT5K or do a resistance check on them and a bomb tester check. In this particular case, when they went to put them into the bomb tester or the spark plug tester, there was no threads left to put them in the slot. So this is important not to over clean your spark plugs once again. Terminal well carbon tracking. So when we're looking at terminal well carbon tracking, this can happen because the cigarette itself or where the B nut and your lead is not making a good contact inside the terminal well. That can cause terminal well carbon tracking. More common than not, though, this is a really big indicator that you have high resistance. And if you have high resistance, this is going back up towards the lead. It's through the lead itself, up towards the mag, putting added stress on the magneto, added stress on the full ignition system, and going to cause issues long term. If it turns out that you just had the cigarette inside the terminal well and it did not make a good contact point, you're able to use alcohol to clean this off. If you can't get it cleaned off with alcohol, you can use a little MEK, but you need to remember that you need to go back with alcohol because MEK is conductive. Don't use carbon tetrachloride. I very rarely don't see anybody that even get carbon tetrachloride anymore. Rotation of spark plugs. So this is a big deal as well. If you want to get even wear on your spark plugs, if you want to get the longevity out of your spark plugs, it's important that you rotate them. We have positive and negative. The plugs fire positive and negatively based on where they are within the engine. In this particular case, this comes on every box of Tempest spark plugs, but you want to rotate them. If number 1 top is firing positive, we're going to know that number 4 bottom is going to fire negative. So you're basically, what you're doing is you're rotating from top to bottom, from the front cylinder to the back cylinder, and you're going from a long lead to a shorter lead in order to get proper rotation on those plugs. And that should happen every 100 hours. The other easy way I find to do this, actually the easiest way I find to do this, is just to take your spark plug tray, and it's hard, you can't see me very well, but if you take your spark plug tray and you put number 1 or top number 1 in that slot, and you go all the way to bottom number 4 or bottom number 6, and you just rotate that tray around. So bottom number 6 is now in the top spot, and top number 1 is now in the bottom number 6 spot. That's another quick way to rotate these spark plugs and get that done correctly. The reason we want to do this, again, is we have, with positive and negative polarity happening, you actually have 3 things that occur. If you do not rotate them, you're going to see positive polarity, and this is going to wear your ground electrode out much faster. And you can see that in this picture than it would if you were rotating the plugs. We're not going to get even wear on them. This is negative polarity. Negative polarity is going to wear out the ground or the center electrode much rapidly if we're not rotating the plugs. And then the last thing that happens from not rotating plugs is that we're putting undue stress again on the ignition system. And the more undue stress that we put on the ignition system, the more likely we're going to have issues with the capacitance after fire, where you're putting stress on the resistor that cause that hard starting, that rough running, the misfiring, etc. The feeler gauge, and I know I'm getting close on my time here. So when we're looking at a feeler gauge, we want to make sure, number 1, that you're inserting it vertically, not horizontally, to check the gap on this plug. And you want to make sure you don't leave the feeler gauge in when you go to gap the plug. Every so often I see that, and we have issues with people getting the feeler gauge stuck in the spark plug. The gapping method is, there are multiple tools and multiple ways to gap spark plugs. Here at my house, I have a donut-shaped spark plug gapping tool. And here at the plant, which we're obviously doing many more plugs, we will hand gap all of our plugs to 16 thousandths for the standard, for a standard magneto or ignition system. And we all use a tabletop, or we use a tabletop gapping tool. So again, there's multiple ways to do it. Just make sure that you follow the instructions before you go ahead and do that. Do not reopen the gap. Simple, this is a double-edged sword. Number 1, I have not found a tool that allows you to reopen the gap without damaging the center electrode or the insulator in some way or some form. So when I say it's a double-edged sword, is that if you gap the plug too tight, and let's say it's supposed to be at 16, but you gapped it at 14 or 15 thousandths, go ahead and run the plug. The gap's going to open up. It may run a little rough, but your gap's going to open up and the plug's going to be fine. If you're getting down and you're into, let's say, 12 thousandths for some reason, yeah, the plug at that point, the gap's too tight and it's not going to fire. So what you're looking at here is you have no choice but try to reopen that spark plug. Most likely you're going to damage it, but you're going to throw it away either way without attempting to do this. So that's why, again, I say it's a double-edged sword. Gapping the fine wire plugs. Number 1, from a Tempest perspective, we say do not gap these plugs unless they're outside of 21 thousandths. We found that people will try to clean them and gap them just like massive spark plugs, and they end up wearing the plug out much faster. And this is why they don't get 2,000 hours out of the plug. So again, wait till they're outside of 21 thousandths. If you see it get to that point, take the feeler gauge, and then you can see here there's a little fork here, and you're gonna gap that plug at the strongest point where the weld is, and pull that plug back down to 16 to 17 thousandths. Testing. So when we test the plug, I talked about 2 different ways to test the plug already. This is what I keep referring to, a bomb tester or a spark plugger. There's many different ones out here. This all goes back again to reading the instructions. These testers work great for allowing you to see whether the electrode's going to fire or not. It does a really poor job of telling you if the resistor is any good. You got to remember that this machine is going to put out way more voltage than any magneto's ever going to put out when you're at altitude. So it's important to check your plug with this machine for the electrode and make sure the plug's firing. It's important that you use an ohm meter or an AT5K to make sure the resistor is good in that spark plug. And by using both, you're going to get a full picture of the health of the plug and hopefully keep that plug running for a long time. Installation, basic installation things. When you're going to use a anti-seize, and we want you to use a graphite-based anti-seize, make sure you stay 2 threads from the firing end side of the plug. Every so often I'll walk into a shop, believe it or not, and somebody's cut the top off of the anti-seize, and they're dipping spark plugs into the anti-seize. That's not a good thing, and your plugs are not going to fire. The other thing that's been out there is that Lycoming has issued a service bulletin that in particular says they want you to use a copper anti-seize. I can tell you from earlier this year when we were at different IA renewals that I spoke with our competitors, and they're in the same belief that we are, that we need to use graphite-based. We feel like the copper base, as the plug heats up and that engine heats up, the copper base will actually, instead of being tacky, it melts and gets into the firing end of the plug. So we're both big believers in using the graphite base, and that's what we recommend. Your gasket application. Number one, make sure you're using a new gasket every time. I know people like to anneal spark plug gaskets, but I promise you, you're not getting the properties back. They're not that expensive. You can buy 100 of them, I think, for less than $15. So it's not going to break the bank, and it's an important thing to do when you're replacing those plugs. The other thing is, I always get asked, what side should the spark plug gasket be installed on? Doesn't matter. They're a crush gasket. When you torque them down, you're going to be good to go. Proper torque. Lycoming has a specified torque. Continental has a specified torque. Make sure you're following those torque specifications. If you're not, now this is an extreme case, but this has occurred. This is where somebody did not replace the gasket. They did not torque. They didn't get a proper reading on the torque because they didn't replace the gasket, and those combustion gases were coming out, and that gasket was no longer a heat sink, and the plugs got so hot that it got over that 4,000 degrees mark and melted these fine wire spark plugs. So it's extremely important that this is taken care of. So in review, always verify proper plug to engine application. Always be sure to use proper tools, use proper cleaning methods, rotate according to the rotation chart, use proper installation procedures, clean, gap, and rotate your plugs every 100 hours or sooner if your application dictates. This is our website. Again, it's www.tempestplus.com. We actually just updated it this year, so there's a ton of detail from application data to cleaning procedures to where to purchase spark plugs. It's a great resource. We also, if you want to subscribe to emails, we're not going to bombard you with a bunch of junk, but if we have specials going on or we have something new from a technical standpoint that we think we can help you out in the field, we're going to send those things out to you. This is my contact information. And I don't know why it went. Let's see if I can go back here. This is my contact information. This is my mobile, my personal cell phone. So please feel free to give me a call. This is my email address. You can email me at tempestplus.com, and I'd be more than happy to answer any questions that we can't get on board here. But again, I really appreciate you guys allowing me to have the opportunity to speak with you, and hopefully I get to see you in person next year.
Thank you, Vince. I really appreciate that. We're going to let hand the camera over here. We've got some questions here. Let's see here. What do we got? What do we got here? How much longer is a fine wire aircraft plug likely to last than a massive wire plug?
Typically a fine wire, so the question was, how much longer will a fine wire plug last than a massive spark plug? Typically that's going to occur about 3 to 4 times. The fine wire plug is going to last 3 to 4 times longer than a standard massive spark plug will.
Okay, good.
So that's going to be, if your massive plug is going to last 500 hours, your fine wire plug is going to last somewhere between 1,500 hours and 2,000 hours.
Okay, great, thank you. Let's see here. Do EGTs correlate with spark plug tip temperatures?
EGTs do not correlate with spark plug tip temperatures. Neither EGT or CHT is going to give you a good read on your spark plug temp. If I had to pick one, I would say your CHTs are going to give you a better indication, but they're not very accurate either when it comes to knowing your spark plug temperature.
Okay, we have a few more questions. I just want to remind everybody to wait around till the end of this, and we'll do the drawing for the Aircraft Spruce gift certificate. Somebody here has asked, how does CHT, this is from Steve, how does CHT compare to plug tip temperature?
Yeah, so it's going to really vary based on the engine, but again, you're not going to get a good reading on your CHT temps or a good correlation between your CHT temps and your spark plug temps.
Okay. Right. You kind of touched with this with the graphite when installing the plugs, but one question was, do spark plug manufacturers recommend lubricating spark plug threads when installing? That's from, yeah, that's Christian.
So the answer to that is yes. We want you to take a graphite anti-seize, put that on the threads, keep it 2 threads above the firing end of the plug. The other thing I would say on this is that more is not better. I see a lot of people that, this is one of those times that putting on more graphite anti-seize is not the answer. You're more likely to get that into the firing end of the plug and cause damage to the plug.
Oh, okay.
Randy had asked, he's having trouble finding the video that you mentioned. It's on your website. He said he can find it in foreign language, but not in English.
Okay. I will check on that later, but now that he says that, I don't want to say 100%, but I'm pretty positive it's on there. You can also go to YouTube as well and find it on the YouTube channel, or just type in Tempest spark plugs and you'll find it on the YouTube as well.
Okay. Here's an interesting question. What is the theory of the spark plugs with the 3 different types of tips? The spark between the 3 different tips.
Oh, I'm assuming the theory on they're asking why we're using a nickel ground electrode versus a fine wire, which is an iridium, and then we use a projected core nose. So the theory in that, the original plugs that were introduced were manufactured out of nickel, and they use a nickel ground electrode and a nickel center electrode. And those plugs work great, but they would last around 500 hours or so. Your iridium tips, they cost more because the iridium takes longer to wear out. The plug's going to last 3 to 4 times longer. The iridium also, the tip runs hotter, so it's going to be less likely to foul out. You also get an easier start when you're running fine wire plugs. And if you're running bigger engines, you're going to get a smoother running spark plug on iridium tips. So those are kind of the 2 differences there. You move to the 3rd design, which is your BY design, and it's very similar to the mass of it. They're both made out of nickel. The difference is with the projected core nose, where that tip itself is going to run a little bit hotter, so it's going to scavenge lead better. And because it's projected, it's going to allow the plug to fire for a much longer period of time before a plug will foul out because of lead issues.
Okay.
And I guess the last thing on the BY before we jump off and move on to the next question is that the BY was specifically designed for those small engines that were designed with 80 octane fuel. And when we went to 100 low lead, all those small engines like your C90, your 200, your C85s, those type of engines were not designed for 100 low lead, so they would foul much quicker. So that's why you brought in the 3rd design of a spark plug with that projected core nose.
Okay.
Okay, and Doug has asked, he says, you mentioned, can you repeat proper leaning procedure, if any, while taxiing? That's one. And the second is, suppose rough mag check on run-up. What is the proper procedure for leaning to clean plug at run-up? He's got a Continental 0470R.
Okay. So when we talk about, again, proper leaning, it really is going to get into more depth in the particular engine and your particular airframe. So I can't get into real particulars on that, to be very honest. But you definitely, you don't want to be running too rich, because that's going to cause carbon fouling. You don't want to be to the point where you're running so lean where that engine it seems like it's starving for some fuel. I've seen people get to that point where they're running so lean, and that's where you get the silicon lead fouling issues, because you're running too aggressive on the ground. The second part of that question was how do you get rid of these things if you have a rough mag check? And the issue is to go where you're running up and doing your mag check and just let that engine sit and run there for a minute or so. And that should clean out any of that carbon or lead fouling. If you continue to see that, then you're going to actually have to pull the plugs and clean them. And then we'd have to diagnose how to fix that from there.
Okay. And I got a question regarding the wires. When your plug's being replaced or cleaned and checked and everything, the tip of the wire, what's the best cleaning practices, if any, for cleaning the spark plug wire itself?
So when you're looking at cleaning the spark plug itself, I mean, typically where you're going to see the dirt and the lead, the fouling, the carbon, that's all going to be insulator, internally inside the insulator. You're not really going to see anything on the electrode. I've seen some people use a little bit of emery cloth from time to time on the ground electrodes. The other thing that people particularly use is if they're using a spark plug cleaner. When they use that cleaner, they're using the walnut, or we recommend the crushed walnut or the black diamond, and either one of those can also clean that ground electrode, those electrodes off as well.
Okay, good. All right, I think that's it for that then. This is wonderful. It's great presentation. Love it. Great.
Yeah, thank you.
So,
thank you for being with us, Vince.
Yeah, thank you very much, Vince. And of course, Aircraft Spruce for sponsoring our webinars today. We appreciate Aircraft Spruce, obviously, and Tempest. And as Vince had shown, there is a website that if you have any additional questions, reach out to Vince, email him, go to the website for additional information and support. And something else just came in here, Vince.
Well, first I want to mention that the information that Vince shared on his slide for contact information is in the chat, so you can go ahead and grab that there. But Ernie wanted to say just a quick shout out to recognize the great support Tempest provides and the excellent response to issues that I've had, as well as those you've supported on the Beach Talk forum.
Oh, well, we appreciate that. We definitely appreciate that. We do our best to support our customers, and it's always good to hear positive feedback.
Ernie Jiggs, I love that. Thank you, Ernie. I appreciate it.
Yeah, thanks, Ernie.
Yeah, thank you. I know, love it. Well,
Okay.
yeah, and thank you guys, everybody, Vince, for being here on a Friday afternoon, and all of you that have attended the seminar today.
Thanks, everybody. I enjoyed it, and again, I hope to see you guys next year.
Yeah,
I know, right?
In person.
Thank you.
Right.
Thank you, Vince, for your time. Appreciate it.
Thanks. Take care.
Bye, everybody.